Good afternoon. So I'm the creative director of the Research and Development Lab at the New York Times, and our lab was founded in 2006 as the Times realized that the rate of technological change wasn't going to slow down anytime soon. And while there's a huge amount of innovation that happens throughout the company, that we needed a way to stay ahead of that curve, to look a little further out and anticipate what might be coming next. So we're a small, multidisciplinary team of researchers, designers, programmers, and data scientists. And what we do is we research emerging technologies and behaviors that we see coming up in the world. And we design and build working prototypes that look at what those trends might imply over the next several years, and what that means for both the production and consumption of news and information. So in order to do this, we're constantly trying to find and interpret signals of change or evolution around us. And it's some of those signals that we're seeing that I want to talk about today. I want to talk about some subtle but important changes that we're seeing in our relationships with and our postures towards algorithmic systems, how those changes are at odds with some of the core values that we've been building into our technology and into innovation for a long time, and what new principles we can start to use to design better interactions for the future, ones where we're empowered to actively engage in negotiations with complex systems. As an interaction designer myself, I'm particularly interested not only in technology itself, but in the new kinds of behaviors and cultural norms we start to see evolve or emerge around new technologies. When we look at kind of past visions of the future, many of them are laughable not because they get the technology wrong, although some of them do, but because they fail to anticipate cultural change that happens either parallel to or in response to technological change. These are two stills from a video from the 1960s about video shopping, and it's actually quite prescient in anticipating a lot about the internet and how that works. But at the end of the segment, the woman's shopping bills are submitted to her husband for review and payment. So it really fails to anticipate feminism alongside any of that. And I've spent a fair bit of time looking at these kind of retro future videos. And one of the things that I started to notice after a while is that some of the core bits of our cultural vision of technological innovation haven't changed much in 50 years or so. So let's take a look at a video of Walter Cronkite in a smart kitchen in 1967.
This might be part of the kitchen in the home of the future. Preparation of a meal in the 21st century could be almost fully automatic. Frozen or irradiated foods are stored in that area over there. Meals in this kitchen of the future are programmed. The menus given to the automatic chef by a typewriter or punched computer cards. The proper pre-packaged ingredients are conveyed from the storage area and moved into this microwave oven where they are cooked in seconds. When the meal is done, the food comes out here. When my meal's ready, instead of reaching for a stack of plates, I just punch a button, and the right amount of cups and saucers are molded on the spot.
It's the 1960s. It's all about plastics. So let's compare that with a video from this year from the Consumer Electronics Show last month. This is a video from Whirlpool.
The refrigerator knows exactly what's in the refrigerator, so whether you're there and you're seeing it or you're away from home, you can be connected and know what's in your refrigerator. And if you decide that you're going to cook a pizza, let's say, you can select that and the oven will start to preheat and prepare for that pizza. It even goes so far that more than likely there's going to be a little bit of a mess on the dishes, and the dishwasher already knows the type of cycle that it needs to prepare for, because those type of dishes are going to be coming its way. And just if it does happen and a little kid spill on their shirts, the washing machine is ready to go, and it knows exactly what is going to be expected in terms of stain removal. So the idea is that these appliances are all connected, they're talking, they're smart, they're anticipating the consumer's needs, so that at the end of the day, it becomes less of a chore and it becomes more of a pleasure for our consumers.
So the tone is different, but we can clearly see a lot of similarities between these visions that are nearly a half-century apart. And when we look closely, we can identify some implicit design principles at work, some values that we've been building into innovation for decades. And the first is that the computer should do things for me. These systems are designed to relieve us of a variety of everyday burdens, from figuring out a recipe to adjusting my lighting. Ease, efficiency, and freedom from the burden of mundane tasks are held as the highest values here. To the designers of these systems, every task has a problem embedded within it. Every bit of labor has a space for optimization and greater efficiency. Potential users might look a little bit like these people. And we highly value this idea that's been marketed by Apple, that it just works. In other words, it works without me ever needing to understand how it works. As a consumer, you should never feel the need to look under the hood or view or examine a system's process, because it should be smart enough to always anticipate your needs. Mother is a good example of this. This is a new product. It's a hub that's paired with sensors that are intended to track anything and everything, from how far you walk to if anyone's in your home, if your plants have been watered, if someone's left the fridge door open. The sensors are these featureless white and colored objects. And as you can see from the copy here, each one seamlessly adapts to its task, even when that task changes. And seamless is a key word here. Even the aesthetic design is clearly intended to dissuade anyone from ever having a view into the inner workings. Follow this path design-wise, and you end up with Doctor Who's sonic screwdriver, a device where nobody has any idea how it works, but it can do anything from pick a lock to kill an alien, and it's only got one button, which actually sounds a little bit familiar. Finally, these systems are designed with just enough inputs and choices to make them seem flexible, but those inputs often reflect the assumptions of the designers of the system rather than the needs of the user. If it's truly smart and it truly just works, then these are the only controls you'll ever need, right? I mean, why would I ever want to do anything other than like something? So why wouldn't I want things doing work for me? Why would I want to understand more about what a system is doing when it just makes the right decisions for me? But that's the problem. These systems are implicitly making decisions on my behalf, and they don't always do what I expect them to do. And as those systems become more pervasive, getting it wrong becomes increasingly problematic. We're starting to realize that these black boxes are insufficient because those systems are never smart enough to do what I expect them to all the time, or I want them to do something they weren't explicitly designed to do, or one smart thing disagrees with another smart thing. And yet, in embodying the implicit values here, where these systems aren't designed for me to be able to see why a decision was made, correct it, or optimize the way I want it to work. And those decisions are no longer trivial. They impact everything from the media I'm exposed to through recommendation algorithms and personalized search, to how my home operates as automation is increasingly integrated through products like Nest and Canary, to what my health insurance knows about my body, about my physical status. I'm guessing this probably doesn't happen as much in Europe, but in the US, many people are giving their private health insurance companies access to their Fitbit or other health sensor data, which could potentially and almost certainly will be used to influence premiums and costs. To how my car behaves on the road, which becomes increasingly important as we move towards self-driving vehicles. To how I move about in the world, how I get from place to place, and the kinds of places that I'm exposed to or potentially not exposed to. To whom I may date or marry. And so what we're seeing is we're seeing people adopt a variety of behaviors to work around these constraints, to deal with the insufficiency of these black box systems. And there are three different kinds of behaviors we're seeing. The first is adaptation. In some cases, I bend to the system's will. For example, and I think this is something we probably all experienced in one way or another, where I have to intentionally mispronounce something in order to get a voice control system to understand me, mispronouncing a friend's name to get my phone to call them, over-enunciating or speaking in a different accent because of the cultural assumptions built into voice recognition. We see people contorting their behavior in order to perform for systems so that they respond optimally. This is compliance. This is an acknowledgement that we understand how we're being listened to, but because the system isn't flexible enough to shape itself to us, we shape ourselves to it. So if this is the way we move forward, do half of us end up with Google accents and the other half with Apple accents? How much of our culture becomes an adaptation to systems that we can't negotiate well with? Another emerging behavior we're seeing is negotiation, ways of engaging with the system to operate within it in more nuanced ways. Like with Ghostery, which is a browser extension that allows me to see what data is being tracked from my web browsing and shape that or limit that tracking according to my desires. So this is the middle ground here. This is where I'm actively probing a system that is intended to be opaque in order to see what it does and try to work with it better, to force it to be more visible and flexible so that I can negotiate with it. We also see this kind of probing of algorithms becoming a new and critical role in journalism as newsrooms take it upon themselves to independently investigate systems through impulse response and reverse engineering, whether it's looking at the words that search engines censor from their autocomplete suggestions, how online retailers dynamically target different prices to different users, or how political campaigns generate fundraising emails. Or on the other end of the spectrum, rather than bending to the system or trying to better converse with it, some take an antagonistic stance, breaking the system in order to assert their will, such as with Adam Harvey's CV Dazzle approach, where I hack my hair and my makeup in order to foil computer vision and opt out of participating in facial recognition systems. And while the attitude here is antagonistic, I'm deliberately opting out of the system, but it's also an extreme recognition of that system's power. I'm changing my identity and my appearance simply in order to exert free will in this interaction. So rather than simply seeing these behaviors as a series of exploits or hacks, I see them as signals of a changing posture towards computational systems. Culturally, we're familiar enough with computational logic at this point that we can understand the computer as a subject, as an actor with a controlled set of perceptions and decision processes. And so we're creating these relationships where we form a mental model of the system's subjective experience, and then we respond to that in various ways. Rather than seeing those systems as tools or servants or invisible masters, we've begun to understand them as empowered actors in a flat ontology of people, devices, software, and data, where our voice is just one signal in a complex network of operations. And we are not at the center of this network. Sensing and computational algorithms are continuously running in the background of our lives. We tap into them for our needs, but they're purely in service of the end user, but also in service of corporate goals, group needs, civic order, black markets, advertising, and more. People become not masters of devices, but human nodes on a ubiquitous and distributed network. And this fundamentally changes our relationship with technology and information. However, these systems are designed so that that complexity is abstracted away from the end user. They're intended to just see themselves and maybe the friendly device at their sides. And in this process of simplification, we're abstracting ourselves out of many important conversations. And in doing so, we're disenfranchising ourselves. Julian Oliver says, our inability to describe and understand technological infrastructure reduces our critical reach, leaving us both disempowered and quite often vulnerable. Infrastructure must not be a ghost, nor should we have only mythic imagination at our disposal in our attempts to describe it. The cloud is a good example of a dangerous simplification at work, akin to a children's book. So what I'm advocating are interactions that acknowledge the peer-like status that these systems have now have in our lives. Interactions where we don't shield ourselves from complexity, but actively engage with it. And in order to engage with it, the conduits for those negotiations need to be accessible not only to experts and hackers, but to the average user as well. We need to give our users more respect and provide them with more information so that they can start to have empowered and nuanced dialogues with the pervasive systems around them. This is obviously not a simple proposition, so we start with, well, what are the counterpart values? What's the alternative to the black box? What's the alternative to it just works? What design principles should we be building into new interactions? And the first is transparency. In order to be able to engage in a fruitful interaction with the system, I need to be able to understand something about its decision-making process. And I want to be clear here that transparency doesn't mean total visibility. It doesn't mean showing me every data packet sent or every decision tree. And I say that because there's a lot of conversation about transparency in algorithms lately, and my slides just went away. I'll keep talking. And people have a tendency to throw their hands up and say, oh, these systems, these algorithms have become so complex that we don't even understand what they're doing, so how could we possibly explain it to you? But I think that's really a straw man here. And the analogy I use is that when I have a conversation with a friend, I don't know his whole psychological history or every factor that goes into his decision-making process, let alone what's happening at a neurological or chemical level. But I understand something about who he is and how he operates. I have enough signals to participate and give feedback. And more importantly, I trust that he will share information that's necessary and relevant to our conversation. Between us, we have the tools to delve into the places where our communication breaks down, address those problems, and recalibrate our interaction. So transparency is necessary to establish trust that a system is doing what it purports to, that it's showing me what I need to know and isn't doing anything I don't want it to with my participation or data, and that it's giving me the necessary knowledge and inputs to correct it when it's wrong. We're starting to see some really nascent examples of this, like this functionality that both Amazon and Netflix have, where I can see the assumptions that go into suggestions that are being made for me. And it gives me a way to give negative feedback, so I can tell Amazon when it's wrong and why. It definitely still feels pretty clunky, but this is a step towards that kind of transparency. More broadly, though, the issue that we're facing with transparency has a lot to do with the shift from mechanical systems to digital ones. So mechanical systems inherently have a degree of transparency in that their form necessarily reveals something about what they're doing. But digital systems don't implicitly reveal their processes. And so it's a relatively new state that designers now bear the burden of making those processes visible and available to interrogate. The second principle here is agency, meaning that a system's design should empower users to not only accomplish tasks, but should also convey a sense that they are in control of their participation with the system at any moment. And I want to be clear that agency is different from absolute and granular control. So something like this gives us an enormous amount of precise control, but if you're not an expert, it probably doesn't give you much sense of agency. A car, on the other hand, is a nice illustration of that balance. There's plenty of smart stuff going under the hood that I can't directly adjust. I can't control how electricity is routed or which piston fires when, but I can intervene at any time, and most importantly, I feel that the car is working at my behest. The last principle, virtuosity, is something that's very important and is usually something that comes as a result of systems that support agency and transparency well. And when I say virtuosity, what I mean is the ability to use a technology expressively. Edward Tenner, in his book, Our Own Devices, talks about the difference between technology and technique. So technology are the structures, devices, and systems that we use, and technique is the ways in which we use them. He uses shoelaces as an example, a very simple technology, yet there are varieties of lacings for specific activities like hiking or football, lacings that indicate military association or country of origin. Apparently, Americans and Europeans do it differently. And color or style of shoelace can indicate everything from cultural affiliation to gang membership. So shoelaces are adapted for needs or desires that range from functional optimization to social signaling. And the simple technology contains the affordance for all kinds of skilled techniques that become deeply embedded in processes and cultures. And it's not just about being able to adapt something to one's needs, but to be able to play a system with skill and expressiveness. And this is really what I think we should aspire to. While it's wonderful if technology makes our lives easier or more efficient, at its best, it's far more than that. It gives us new superpowers, new channels for expression and communication that can be far more than utilitarian. They can allow for true eloquence. So we need to design interactions that allow us to eloquently converse across complex networks where we can understand and engage in informed and thoughtful ways, and the systems around us can respond with equal nuance. These values deeply inform the work that we're doing in the Times R&D Lab, whether we're building new interactions on top of existing devices to give users more agency within a recommendation system, or exploring new kinds of environmental computing interfaces that respond across multiple systems, or developing best practices for how we manage and apply our readers' data. By doing research to understand the technological and behavioral signals of change around us, we can then build and imagine futures that best serve our users, our company, and our industry. Thank you very much.
Thank you so much, Alexis. We have a lot of questions.
Oh boy.
Where should we start? It's also very funny, right? We're writing it on paper. It comes through Twitter, but then we write it down. Someone is asking, why do we have to shape ourselves to technology? Can't we just opt out? Probably yes, right?
I think that in some cases we can, but increasingly there are systems around us that we can't opt out of. And you see that in the example of CV Dazzle, where there are computer vision systems around us, there are cameras around us that are being used for facial recognition, for identifying people, for tracking people. And there's not really a good way to opt out of that. Those systems are designed intentionally not to be opt-outable. So I think that, you know, in some cases we can, but in others we can't.
Yeah, but we need to remain active and aware of that. So we heard some bad examples today about R&D labs. What does it make that the NYT R&D lab works so well? Or do you have some principles to share also about maybe the team dynamics? Or?
Sure. Well, as I said, I think one of the things that's different is that we are not the only source of innovation within the company. There's a huge amount of innovation that happens throughout the times that you can see every day on our website and in our apps and everything. But that innovation tends to happen on a shorter cycle, so what's happening in the next 12 months, say.
Right.
And so our role is to kind of look around corners and look a little further than that. And in terms of how we operate within the organization, we iterate really quickly, we prototype, and we make sure to really bring in people from around the organization who would have an interest in what we're working on or who have a stake in it, and we bring them in as collaborators as early as possible so that we're not just working as an isolated team and then trying to kind of force our work onto others.
And so another question was, how do you connect to production? So is there a specific interaction point, or is it like very fluid? And
it depends on the project. So there are some things where we have a real clear sense of where something might go, and so we work with those teams early on, and we do that transfer sort of smoothly and organically from the beginning of a project. Other projects we build are a little further out and are really intended more to be provocations or conversation starters, where they're about starting dialogues within the company about what we see happening, you know, maybe 5 years out, and how we might want to prepare for that or think about that as an organization.
And do you use your space a lot? Like
yes.
Do they come to your lab? And
yeah, we do. I mean, so people definitely come through the lab. We build a lot of stuff that's installed in the space. But we're integrated as part of the company.
Yeah, maybe another last question. Some people ask if you could comment a bit about the most popular 2013 New York Times stories and if you see a pattern in there. And
I'm not going to comment on that.
So I think we leave it here then.
Okay.
Thank you very much, Alexis.
Thank you.
Such a pleasure having you.